Hi, Assalamualaikum. My name is Siti Aisyah binti Mokhtar with matrix number of 1170262.
My name is Nashahirah binti Rozlan. My number matrix is 1170264.
Hello everyone. Today, we're gonna learn about renewable energy, wind power. The definition of the wind power. Wind power, or wind energy, describes the process by which the wind is used to generate mechanical power, or electricity. Wind turbines convert the kinetic energy in the wind into mechanical power. This mechanical power can be used for specific tasks, such as grinding grain or pumping water. Nowadays, it can be converted into electricity by a generator. Wind turbines work on a simple principle. Instead of using electricity to make wind, like fans, wind turbines use wind to make electricity. Wind turns the blades of a turbine around a rotor, which spins a generator, which creates electricity. Let's watch the video on how wind turbine work.
How does a wind turbine work? You've probably seen a wind farm. But do you know how wind force is converted into electrical energy? We are going to show you how a wind turbine works. Each wind turbine has a wind vane at the top that indicates the wind direction. This allows the turbine to rotate on the tower and face the wind. The blades also rotate on their axis for maximum resistance. Wind force, that is, the kinetic energy contained in moving air currents, spins the blades. These are designed to fully capture its energy. They can be as long as 60 meters each and are made of very light and resistant materials for ease of movement. This is why they can produce energy even with very light winds, starting from about 11 kilometers per hour. With very strong winds, above 90 kilometers per hour, the blades are placed in the feathered position and the turbine stops spinning for safety reasons. The blades are attached to the wind turbine through the hub, which is coupled to the low-speed shaft. The low-speed shaft is given this name because it spins at the same speed of the blades, between 7 and 12 revolutions per minute. To produce electricity, it is necessary to increase the turning speed of the low-speed shaft. That is the mission of the gearbox, which raises the speed over 100 times and transfers it to the high-speed shaft. The high-speed shaft, that rotates at up to 1500 revolutions per minute, is connected to a generator. The generator converts the kinetic energy into electricity, a source of energy that is easier to transport and use. The electricity produced in the generator is conducted through the interior of the tower to the base. There, a transformer raises the voltage for transport inside the wind farm. From each turbine, alternating current is sent to the substation through underground cables. Here, the voltage is increased again to feed it into the power grid and transport it to end consumers. This is how we use the wind to light cities, feed industries, schools or hospitals, or operate our household appliances in a clean and sustainable way.
The wind turbine can be classified into two, according to its design and size. There are two basic types of the wind turbine, which is horizontal axis wind turbine and vertical axis wind turbine. There are also available in different size depending on their application, such as utility scale wind turbine and smaller wind turbine.
Wind turbines are mainly of two types:
horizontal axes and vertical axes. Horizontal axes wind turbines are more common. In case of horizontal axes wind turbines, the rotating axis of the turbine is parallel to the ground, and they are mainly used in commercial, big-purpose projects, producing electricity at a large scale. This type of wind turbine are generally very high, and their installation cost too is very high. They are installed at places where the wind conditions are very consistent. Vertical axes wind turbines. In case of vertical axes, the rotating axis of the turbine is vertical to the ground or perpendicular to the ground. They are primarily used in small wind projects and residential applications. They are able to work in places where wind conditions are not very consistent, and they can rotate in even lower wind conditions. They are not very high. They are closer to the ground. They are quieter and more bird-friendly. That is, lesser number of birds are harmed in case of vertical axes, wind turbines, and these resembles an egg beater.
Utility-scale wind turbine is work at 100 kilowatts and reach up to even a few megawatts. There are also the really large turbines that usually seen in wind farms. These turbines serve as the primary source of electricity in the electrical grid. Small wind turbines. They are usually lower than 100 kilowatts, and they are most used to directly power a home, farm, or small business, and are typically used in remote, off-grid locations, where it is not connected to the utility grid. Wind farms are one of the example of utility-scale wind turbine. Wind power plants, or wind farms, are clusters of wind turbine, grouped together, to produce large amount of electricity. Choosing the location of wind farm is known as siting a wind farm. To build a wind farm, wind speed and direction must be studied, to determine where to put the turbines. As a rule, wind speed increases with height and over open area with no windbreaks. The site must have strong and streety winds. The best sites for wind farms are on hilltops, the open plains, through mountain passes and near the coasts of oceans or large lakes. Turbines are usually built knots rows into the prevailing wind. Place JNG turbines too far apart waste space. If turbines are too close together, they block each other's wind. Second is offshore wind farms. Because cool air from the water is always moving inland to take the place of warm water that has risen, the wind blows stronger and steadier over water than over land. There is no obstacles on the water to block the wind. There is lot of wind energy available offshore. Offshore wind farms are built in the shallow waters off the coast of major lakes and oceans. Offshore turbine produce more electricity than turbine on land, but they cost more to build and operate. Some challenges for offshore wind farms include the costs and difficulties involved with water-based construction, and maintenance of parts. Europe is currently leading the offshore wind industry with over 90% of global offshore wind installation. The United Kingdom, Denmark, China, Belgium, Sweden, Finland, Germany, the Netherlands, Norway, Japan, and Ireland all have offshore wind turbine. Lastly is small wind turbine. Wind turbines are not only on wind farms, or offshore, they can also be found on the property of private residents, small business, and schools. A typical home uses approximately 911 kilowatt-hours of electricity each month. Many people are choosing to install wind turbines to lower or eliminate their electricity bills. Sitting a small wind turbine is similar to sitting a large wind turbine. Potential small wind users need to make sure that there is plenty of unobstructed wind. The tip of the turbine blades should be at least 9 meters higher than tallest wind obstacle. Sometimes this can be little challenging for installing a residential wind turbine if local zoning laws have height limitations. The turbine also requires open land between the turbine and the highest obstacle.
What makes a good wind power site? A high average wind speed, such as on top of a hill or in a wide open space with no obstructions nearby. Any site that has an annual average wind speed of 7 meters per second or more would be considered excellent for farm wind turbines. Sufficient separation from noise-sensitive neighbors. Modern wind turbines are remarkably quiet. Next is good grid connection. It requires a suitable 3-phase electrical supply to connect. As a rough guide, you will need an 11 kV transformer or substation. The last one is no special environmental or landscape designations. A lot of the older objections to wind turbines due to bird strikes have now been shown to be unfounded. Peat bog is also generally a no-go area for wind turbines. Characteristics, properties and design of wind turbine. Tower. Wind turbines are placed on towers reaching anywhere from 40 to 90 meters high. Because there is less air turbulence at greater heights, wind turbines are most effective mounted on tall towers. Grounding equipment. It is found at the base of wind turbine towers. Grounding equipment, primarily copper, helps to protect the turbines and people from lightning strikes. Size. The size of wind turbines varies with their use and location. The average wind turbine in a wind farm has a 50 to 90 meter blade diameter with a tower height in the same range, while an average offshore wind turbine has a blade diameter of 110 meters. Last but not least is materials used. In order to remain competitive with existing technologies, the optimization of wind turbine efficiency is crucial and dictated by engineering design complemented by judicious choice of materials. The materials should be durable, ideally recyclable, and low cost in terms of manufacture. Let's move into components and functionality of wind turbine. A wind turbine consists of four main components. They are tower, rotor, blade and nacelle. Blade lifts and rotates when wind is blown over them, causing the rotor to spin. This picture shown a comparison of the design features of a current state-of-the-art blade versus a blade from the 1980s. The modern blade is 90% lighter than the scaled 1980s technology. The upper blade is the current generation technology blade while the lower one is the blade during 1980s. So what is the key innovation that had been done? Higher tip speeds to reduce torque and minimize drivetrain weight, higher speed and high-lift airfoils for a slenderer, lighter blade, and innovative tip shapes to manage noise. Nacelle sits atop the tower and contains the gearbox, low and high-speed shafts, generator, controller, and brake. As the nacelle contains mostly mechanical parts of the wind turbine's operation, the materials are not particularly subject to many deviations and variations. Tower. It supports the structure of the turbine, made from tubular steel, concrete, or steel lattice. The materials must be strong and robust in nature to withstand harsh environmental conditions and strong winds. Blades and hub together form the rotor. The rotor generates aerodynamic torque from the wind with its rotating motion as the blades spin. Other components. In wind turbine, it also consists of anemometer, controller, brake, generator, gearbox, high and low speed shaft, pitch, wind vane, yaw drive, and yaw motor. Anemometer. It measures the wind speed and transmits wind speed data to the controller. Then, controller will starts up the machine at wind speeds of about 8 to 16 miles per hour mph and shuts off the machine at about 55 miles per hour. Brake. It stops the rotor mechanically, electrically, or hydraulically, in emergencies. Many windmills today use air brakes like those used in planes. Next is generator. It produces 60-cycle AC electricity. It is usually an off-the-shelf induction generator. Gearbox connects the low-speed shaft to the high-speed shaft, increases the rotational speeds from about 30 to 60 rotations per minute (RPM) to about 1,000 to 1,800 revolutions per minute. Since it is a costly and heavy part of the wind turbine, engineers are exploring direct drive generators that operate at lower rotational speeds and don't need gearboxes. High-speed shaft drives the generator and low-speed shaft turns at about 30 to 60 revolutions per minute. Pitch turns, or pitches, blades out of the wind to control the rotor speed, and to keep the rotor from turning in winds that are too high or too low to produce electricity. Wind vane measures wind direction and communicates with the yaw drive to orient the turbine properly with respect to the wind, while yaw drive orients up wind turbines to keep them facing the wind when the direction changes. Yaw motor powers the yaw drive. The environmental impacts of wind power. While wind energy is a clean and renewable source of power, there are negative environmental ramifications associated with the construction and operation of wind turbines. Here are a few of the downsides to consider when generating electricity with wind turbines: bird and bat mortality, soil erosion and deforestation, noise impact, and the last one is disco effect, shadow flickers. Bird and bat mortality. When the blades of wind turbines rotate at high speeds, the air pressure around the blades shifts and increases the likelihood of birds and bats colliding with the blades. However, the exact impact on local bird and bat life can vary dramatically from one wind farm to the next. However, when compared with other renewable energy sources, the impact is smaller. Many researchers have recommended that a proper location of a wind farm significantly reduce the bird and bat mortality. Soil erosion and deforestation. Soil erosion and deforestation are major ecological influences of wind energy farm development. Several activities, such as the excavation of foundations, roads, and projected lands during the construction of the wind energy farm, affect the local biological system. China's wind turbine construction guidelines suggest that excavation should involve as much work as possible to minimize heavy equipment interference. In addition, after construction work, it should be recommended to replanting trees as early as possible. Noise impact. The wind turbine's noise can be divided into two main types, that is, 1 aerodynamic and 2 mechanical. Aerodynamic noise is generated by airflow flowing above the turbine blades and produces a characteristic, howling, sound. Therefore, turbines should be retreated from residential and property lines to protect participating and nearby landowners from noise and safety issues. Disco effect, shadow flickers. Shadow flicker caused by blade motion and reflection of sunlight on the wind turbine body, so-called disco effect. The shadow flicker caused by the wind turbine changes with the intensity of the light produced. Shadows are cast on the ground and stationary objects, such as houses, by moving the blades. This will cause disturbance to residents living in the area around the turbine. It can be minimized by optimizing the smoothness of the rotor blade surface and by coating the turbine with less reflective material.